Hello friends, myself R.D. Mahajan presenting my video on the topic linear differential equations with variable coefficient. Type 1 Cauchy's form. Its general form is x raised to n nth derivative of y with respect to x plus p1 x raised to n minus 1 n minus 1 or n minus first derivative of y with respect to x. Next, p2 x raised to n minus 2 multiplied by n minus second order derivative of y with respect to x plus so on pny is equals to phi of x. Here if you see, the coefficient of every differential coefficient is in terms of x, a variable coefficient. That's why it is called as with variable coefficient. And p1, p2, pn are some constant terms. And to convert it into linear differential equation with constant coefficient, I have discussed so far. Where to substitute log x as z in equation 1. Transferring this to right hand side, we get x is equal to e raised to z. Capital D stands for the operator d by dz. We get dy by dx is equals to rewriting it as dy by dz into dz by dx, applying chain rule, function of function. Then differentiating this z with respect to x, its derivative is 1 by x, therefore it becomes 1 by x into dy by dz. Cross multiplying it, we get x into dy by dx as dy by dz. Then converting that d by dz as capital D operated on y, therefore we get x into dy by dx as d operated on y. First result. Then again differentiating it with respect to x. Here it is, we have to apply product rule. First term x, derivative of the second term with respect to x, that is d by dx of dy by dx, plus second term as it is dy by dx. Derivative of x is 1, and differentiating it right hand side also with respect to x, we get d by dx of dy by dz. Then x into this become d2y by dx square is equals to this d by dx of dy by dz we rewrite as d by dz of dy by dz into dz by dx, so that dz get cancelled. Once again we get that term d by dx, and then transferring this dy by dx to right hand side, we get minus dy by dx. We rewrite this dy by dx like this. We have it is x into d2y by dx square is equal to this become dz by dx, derivative of z with respect to x is 1 by x d2y by dz square minus this dy by dx we rewrite as d by dz of dz by dx that dy by dx we rewrite as dy by dz into dz by dx, so that dz can cancel, we get once again the term dy by dx, and then it is 1 by x into d2y by dx square minus dz by dx, the value of dz by dx is 1 by x into dy by dz. Cross multiplying by x throughout, we get x square into d2y by dx square as d2y by dx square it becomes d2y by dz square, and therefore it is d2y by dz square minus dy by dz. And then converting in symbolic form, it is d by dz is capital D, therefore it is d square minus d operated on y. We get, therefore it is equals to d minus 1 into y, and therefore we get first one x dy by dx as d operated on y. Second result, x square d2y by dx square as d minus 1 into y, and so on. And therefore, if we put that values in that given differential equation, it is converted to a linear differential equation with a constant coefficient. How? That I will explain with the help of one simple. Solve x square d2y by dx square minus 2y is equal to 1 by x. Here y is dependent variable, x is independent. Degree of this differential order of that differential equation is 2 and degree 1. This d2y by dx square is multiplied by x square variable coefficient, and therefore a given differential equation is x square d2y by dx square minus 2y is equal to 1 by x, we call as equation 1, is in Cauchy's form. And as it is in Cauchy's form, we put that log x as z, transferring this to right hand side, therefore we get x is equal to e raised to z, new independent variable, and using capital D as operator d by dz, we get we have x into dy by dx as capital D operated on y, and x square d2y by dx square we are getting as d minus 1 into y. Substituting this in equation 1, equation 1 becomes and therefore x square d2y by dx square we replace by the term d minus 1 into y minus 2y, and that is equal to 1 by x. The value of x is e raised to z, therefore it becomes 1 by e raised to z. Then taking y common from it, rewrite it, we get d into d square minus d and minus 2 into y, operated on y is equal to, transferring this e raised to z to numerator, we get e raised to minus z. And we call this as equation 2. Here that equation 2 is a linear differential equation with a constant coefficient. It is LDE with constant coefficient. And as it is with constant coefficient, we apply the technique. We find CF, complementary function, and PI part to get the complete solution. And therefore, auxiliary equation is d square minus d minus 2 is equals to 0. Factors of 2, d minus 2 and d plus 1. D minus 2 and d plus 1 is equals to 0. It gives you, equating each to 0, we get d is equals to 2 and d is equals to minus 1. Here the roots are real and different, and therefore applying that first case of CF, we write down the CF as. We get CF is equals to C1 e raised to 2z plus C2 e raised to minus z. We call this as equation 3. Then next part, PI part, it is 1 upon d square minus d minus 2 operated on e raised to minus z. The term on the right hand side is of e raised to x type. We apply the rule of finding pi. D replaced by a is here, coefficient of z as minus 1, and therefore we get one upon minus 1 square minus 1 minus 2 into e raised to minus z. And therefore we have 1 by minus 1 square is 1 plus 1 and minus 2 into e raised to minus z. Denominator becomes 0, 1 by 0 into e raised to minus z. Case fell. And as case fell first time, we write next step as here z into 1 by differentiating it with respect to d, we get 2d. Derivative of d is 1 with minus sign, therefore it is 2d minus 1. Replace d by minus 1, we get 2 into minus 1 as minus 2, minus 1, minus 2 minus 1 is minus 3. Therefore pi is z divided by minus 3 into e raised to minus z, and we call this as equation number 4. Then take the addition of CF and PI to obtain the complete solution. Therefore, complete solution is CF plus PI. CF is C1 e raised to 2z plus C2 e raised to minus z, and PI is minus z by 3 into e raised to minus z as the required solution. Original equation is in terms of x and y. Therefore, final solution also must be in terms of x and y. Therefore, once again we convert the terms of z in terms of x. E raised to z is x. Therefore, it becomes C1 e raised to z and its square plus C2 1 by e raised to z minus z by 3 into 1 by e raised to z, and then it is equals to C1 e raised to z is nothing but x its square plus C2 1 by e raised to z 1 by x minus z, the value of z is log x divided by 3 into 1 by x is the required solution. Some more I will discuss in my next video. Therefore, if you are watching my videos, please like and share it, as well as subscribe to my channel to get new updates or new videos. Thank you very much.